Yes, with a
Oh, yeah.
strong base like sodium amide, we are going to do an E2. So with my first equivalent, I am going to form an alkene, but I still have one bromine, right? Because I only did one elimination. What's going to happen with my second equivalent?
It's going to form a triple bond.
Yep, you're going to do another elimination. So now you're going to get a triple bond like that. Okay. Well, it should look a lot cleaner than that, but you know what it should look. So now I've used two. What is going to happen with my third equivalent? We did something like this a little bit earlier. What's not drawn there?
Is it going to take the hydrogen?
Yep. So now I'm going to form this alkyne is going to have a lone pair like this. All right. So your intermediate here would be this. Oh, all right. Wait, hold on. We're not done yet. Sorry. I missed step two. What's step two?
It's the second equivalent, right? Or the
Nope.
first equivalent.
Step two here. I put a box around.
Oh,
What am I adding?
The H.
Yep. So I'm just going to put it back. So I'm just going to end up with a neutral terminal alkyne like that. The reason why we use three equivalents is just to make sure that we get the alkyne point, right? So we're just going to take the alkyne. So if you just had the Na and H2, you would get this. This would be it. But this second step means you put the proton back. Does that make sense? Okay. Now I'm going to erase this. And now we're going to, so this is what you should have here. In our next arrow, what do we do in the first step? It's the base again, right? We are removing this proton. So when we add NaNH2 like this, we are going to form this. And now what's it going to do in step two? This is a good nucleophile. We are simply going to attack this carbon and do an SN2. We're just adding this carbon chain to the end of this alkyne. Does that make sense?
So can we just draw an ethyl instead of?
Yeah, I just wrote that so you can see what's there clearly.
Okay.
That's just to like clearly show that. But yeah, you could write ET or like two carbons if you want to draw. Like you could draw this, or you could draw this if that makes it easier. They're all the same thing.
Would the BR still be included?
Nope, you kick. That's your leaving group.
Oh, okay.
Because this right here, this is your electrophile, right? This is your substrate. So that bromine is the leaving group. So when the lone pair on the triple bond attacks the carbon, it attacks that carbon and kicks off the bromine. All right, questions? All right. Let's continue on. Provide an IU pack. We'll skip this for now just because I think you guys are okay with it, but we'll come back and take a look. Let's go down to here. Okay, predict the major elimination product for each of the following. Clearly indicates stereochemistry R and S and E and Z of the product. So in this one, what is always going to be preferred, E or Z?
Z.
E.
E, because it's more stable. Isn't it more stable?
Yep,
when
E
it's
is
opposite?
trans. So E equals trans. And Z equals cis. And so I know some of you are sitting there saying, Well, how does E equal trans? How does E equal cis? Well, Z, of course, is short for the word Zusammen, which, if you know your German, means same. And E is short for etrogen, which is, if you know your German, of course, which you all do, is German for opposite. In case you're wondering where the E and Z come from. The reason why we do this is that we have run into some problems. When you want to do this, you're going to want to form, if you can, the E, and then this is where we're going to run into everyone's favorite issue of, what's that called? Hoffman versus Zaitsev. So we know that these are E2 reactions, so we don't have to worry about any of that. Small base or bulky base? Small base. So we're going to take from the more substituted carbon. So our bond should look like this. And that is the E product. Potassium terpretoxide, small base or bulky base?
Bulky.
Bulky. So we are going to take from the less substituted carbon. And again, the key term there is tert-butyl. If you have tert-butyl or isopropyl or stuff like that, that's your key indication that it's going to be bulky. Okay, sodium hydroxide, small or bulky? Small. So we want to take from the more substituted side. And again, it doesn't matter how you draw that double bond. If I draw, the one on the left probably looks a little bit better, but if you were to draw it like this, it's essentially the same thing. Right? You're just drawing that double bond there, but that's it. Just know that you're just drawing the double bond. Questions on those three? How are you guys feeling on those? This is all that's happening here. If you get a section like this where you're doing your this, and then also don't forget, if you have to worry about a stereocenter, worry about it. But in this case, we're losing them, right? Our stereocenters are going away when you form a double bond. However, if you are, if there's a stereocenter away from your elimination, then you have to worry about making sure you're keeping it. But okay, I'll let you guys try to work on these two, and I'll see what you get.
Were those all E2?
Those were, yeah, that's what it told us. These are all E2. Or sorry, no, these are all elimination products, but these were all strong bases. So OCH3 minus, OTBU, and OH minus, those are all strong bases. So those first three were all E2 just because they were strong bases. Whatever lie you got to tell yourself, Gwen. Whatever lie you got to tell yourself. Okay, in our first one, is this going to be an E2 or an E1?
Is it E2?
It's an E2 because it's sodium ethoxide, right? That O minus is usually a good indicator, right? So this is going to be an E2, so we don't have to worry about, because we only have one beta carbon, therefore this, and then our stereo center that's over here is going to stay the same, like that. Okay, our next one, is that going to be E1 or E2?
E1.
E1, because remember when we have alcohol, sulfuric acid, and heat, we are losing the alcohol, we are forming E1. And now we are going to have everyone's favorite rearrangement. That's going to be our product.
Is that a methyl shift?
Yep, because when you form a secondary carbocation, right here, right, next to a quaternary, you have a methyl shift. When it's a secondary next to a tertiary, you have a hydride shift. How's it going, Morgan?
Pretty good.
Are you sure?
Yeah.
Okay. Are you lying to me? Are you lying to yourself?
Positive vibes only.
You know, when I now whenever I play like Call of Duty or Halo Online, when I toss a grenade, I just yell vibe check. So I pause real quick.
So maybe you should play with him.
Maybe not. So this is what you should have. So did you get this one for your answer? Gwen, looking at
Is
you.
that like, is there like a trans or like a Hoffman or anything we have to worry about with this one?
No, because it's an E1, so your E1's going to favor Zaitsev. But what's going to happen? I'm going to erase this real quick. I'm going to draw the intermediate. So when you form your carbocation, this is what you have, like this, right? So one of your methyls is just going to pop over. Then you're going to form this as the, like this. So this would be your carbocation now here. And so when you do an E1 reaction, just assume that it's going to be a Zaitsev. So you're going to take the proton from here. And now you have a methyl. So you have a CH3 and a CH3. So if one side of the double bond has the same two things, so if you think about cutting it like this, you have a CH3 and a CH3. If they're the same, there's no cis or trans. They have to be different.
And the Zaitsev is more stable?
It's not that it's more, yeah, it's going to be more stable because if you form a double bond, you're forming it between a tertiary carbon and a tertiary carbon. That's more thermodynamically stable. I want to say, I think it's more thermodynamically stable. More stable product. We'll just say that. All right, let's continue on. Oh, provide the product for the reactions below. So I will give you guys, I'll give you guys a minute on this one. It's two products. Now I need to make 2 PowerPoints for tomorrow. I don't want to. Okay, so this is one of our many H2 reactions, right? So H2 and platinum is going to be our easier one. Does H2 and platinum react with both or just one of them?
Just one.
Nope. H2 and platinum, this is your every double bond, every triple bond will be gone. So you would just simply draw what you have. So this double bond goes away and this triple bond goes away. And then just make sure you have 1, 2, so 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and then your 8th carbon is down here. H2 and platinum gets rid of every double bond and triple bond. You will hydrogenate every one of those. Does that make sense? Okay, your next one, H2 and Lindlar's catalyst. This is the poison catalyst. Does H2 and Lindlar's catalyst react with alkynes or alkenes?
Alkynes?
Yep, it only reacts with alkynes. So the alkene on this side is going to stay as is. Now, when it reacts here, is it going to make a cis double bond or a trans double bond?
I want to say trans.
This one's cis,
Oh,
like that. So it's going to make a cis. You could also have drawn it this way too, in case you are.
so the triple bond doesn't like entirely disappear.
No, because Lindlar's catalyst in H2 only reacts with alkynes.
Okay.
It turns alkynes to alkenes. Lindlar's catalyst is poison, remember. It does not react with alkenes whatsoever. It just cannot. Like all of you, it just can't. That was a pot shot. Questions on that? Okay. Don't forget, I have done the other practice exams in order. So if you look at the YouTube channel, that's under my name. The other two are there. But again, Morgan, before we leave today, we will take a look at those other ones to make sure those are the ones you're talking about.
I've got a question.
Mhm.
So when we see H2 and Lindlar's catalyst and H2 and platinum,
Mhm.
we can think of the rest of the compound as an R and just put that in.
Yeah.
And treat it accordingly.
Yep. Provided your PI or not your PI, your professor is okay with that, provided that they're fine with that, that's fine. But basically, yeah, it's just the double bond. So if it's H2 platinum, all of the pi bonds are going to go away. If it's H2 and Lindlar's catalyst, only the alkynes are going to go away. All right, so these are the reaction trees, but we'll come back to these. Let's look at the multiple choice because I think these ones are a little bit more helpful. So which reaction has a rate that depends on the concentration of both the nucleophile and the substrate? Nucleophile and substrate. Which of those answers looks to be correct?
SN2.
SN2, right? What can you get rid of right away?
E1.
E1, remember, eliminations involve bases, right? So you can get rid of that. Also, carbocation rearrangement, you haven't talked about those as a family of reactions. Those just happen. They don't depend on anything, right? It just depends on if you have a secondary next to the tertiary or quaternary, right? It's not a class of reactions that we talked about. And so an SN2 depends both on the concentration of nucleophile and substrate. Good job. Which base is the best for an E2 reaction? In E2, are we using weak base or strong base?
Strong base.
Strong base. So which of those are my strong? Which one's my strong base?
Is it number 2?
4. Remember, Gwen, as we talked about earlier, OH minus. OMe minus, OET minus. These are all reagents that are both strong nucleophiles and strong base. I cannot beat it any harder into your head unless I literally hit you with something. You guys need to commit these three to your memory. Okay. I'm not trying to be a dick. I'm just trying to help. I want that to be clear.
The only
Question.
those are the only ones that indicate E2.
No, those are the ones that can go E2 or so your 7 strong bases that you are going to see as E2: sodium hydride, sodium amide. These don't pop up too often, but these are this can kind of pop up. Sodium hydroxide, sodium methoxide, and sodium ethoxide. These are your common ones that you're going to see for E2. And then potassium tert butoxide is the other one. And then I think I've seen LDA once. This is lithium diisopropylamide. These are your 7 common bases for E2. If you see any of these are the ones that you should immediately think of for E2. So small bases for E2, bulky bases for E2. These ones are usually for alkynes or something like that, or alcohols, but you can use them for E2, but those are strong bases. So those are the 7 that you should keep in mind. You guys have them written down? Okay. Question C. Which reaction goes through an anti-periplanar transition state, also called anti-coplanar? Any guesses? Anti-periplanar is going to be E2. The reason what this means here is that when you have your elimination, the proton you take, so when your base comes in, when your basey boy comes in and takes your proton, it has to be they're pointing opposite directions, right? Your hydrogen's pointing this way, your leaving group is pointing, so that's what the anti means. Periplanar or coplanar means that they are in the same plane. Does that make sense? So anti-periplanar, you guys, maybe I should just have a session where I teach you guys how to take notes. If I had more time, I could do that. Which solvent is polar aprotic? Which solvent is polar aprotic? Mag, which solvent is polar aprotic?
DMSO.
Mag, your voice got deeper. I'm very concerned. Yep. So this is how you guys tell if it is polar protic or polar aprotic. If your solvent has an OH or an NH, it is polar protic. OH, protic. H2O, protic. OOH, H2O, protic. This is the only one that doesn't meet that. This is technically sulfur double bonded to oxygen, 2 methyls coming off.
Also, I think she had fluorine and hydrogen as one of them.
Yeah, that basically if it can do a hydrogen bond. So that's a pretty weird solvent, but her class.
So it's gonna be 4.
3.
All right, yeah.
Dimethyl sulfoxide. Great solvent, hard to get rid of it. It's got a very high boiling point. You don't need to know that. That's just if you do research with it. Okay, finally, last one. What will help favor an SN2 reaction with a secondary alkyl halide? What will favor an SN2 reaction with a secondary alkyl halide?
Polar aprotic solvent.
Yep. Heat is going to favor E2. Polar protic solvent is going to slow the rate down. Strong base is going to favor E2. Polar aprotic will allow the reaction to go forward. Does that make sense? Questions? How you guys feeling?
Okay.
That's all you need to be right now. So going back up to these trees, these are directly from the notes, right? So just write them down and work over them, but these are just your alkene reactions. So this is what I'm talking about. Maybe if you made one like flashcard that had all of these reactions, so you know what's happening on each one. So alkene plus KMNO4 gives me a diol. Alkene plus this, I add a Cl and an H, I get rid of the alkene, I add an OH and a Br, I add an OH, right? I just know what I have to add quickly. If you get flashcards, it gets stuck in your head. So like right now, it's not that I'm any smarter than any of you. It's not that I'm any better at this than any of you. I just did so many flashcards with these. I looked at them and I studied them till I drilled them into my head. When I have gone insane and have dementia as an old man, I'm going to say things like polar protic. Oh, SN2 favors this. And my poor healthcare worker is going to look at me. And I'm going to be like, I'm also going to say things like, he's a chunky boy. And they're just going to pull the plug on me. But this is it. So like, if you take this, just know whenever I have an alkene, make a flashcard that has this, right? Make a flashcard that has this and just go through all of them and know what's going to happen. All right. That's very useful. Does that make sense? Okay. This is just flashcard memorization. It's the best I have to offer. So tomorrow we will work on our next. I will send you guys I think I have an exam, a practice exam from my time that I can send you with an answer key. So I will dig through my stuff. So then we can do practice SN1, SN2, E1, E2, and we can do some alkene reactions. So I will dig through my stuff and find them and send them tonight. We will work on that, or we can work on general problems. Okay.
Like we also, like Morgan was saying earlier, we have like an actual exam that we can take. So I can also send you those questions as well if you would like.
Yeah, if you want to do that, hold on as I hit